Math stars. Some of us had some misconceptions about subtracting rational expressions, so I wanted to make another video and talk about this before we dive into the new notes. So just bear with me. This will be short. Please give this your best effort. We're going to rewrite the expressions and factor only the denominators. So factoring the first denominator is a difference of two squares. We're going to factor the second denominator as a greatest common factor. Okay, so when you find a common denominator, you want to think about these denominators like jealous siblings. So this sibling on the left looks at the sibling on the right and notices, oh, it's no fair. My brother has a 3. I want a 3. So the 3 here, this is its own factor. It's a totally different factor than x plus 3 or x minus 3. So the jealous sibling on the left wants a 3. Sure, you can have a 3, but we also need to multiply the numerator by 3. When we multiply by 3 over 3, it's the same as multiplying by 1, so it does not change the value. Sibling on the right looks over at sibling on the left. It's like no fair. Sibling on the left has an x plus 3. Okay, fine. You can have an x plus 3 as long as we multiply by that x plus 3 in the numerator and the denominator. Let's put parentheses around this x minus 1 to show that we're multiplying. So parentheses are really important in multiplication. Okay, do we cancel? No, we don't cancel until the end. Everybody say that with me. We don't cancel until the end. Students out there listening, do we cancel yet? No, we don't cancel until the end. We're going to put everything over the denominator and make one fraction. Do we cancel? No, 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 no. Let's get some Michigan State green on the video here. This minus sign here shows us that we don't have all multiplication in that numerator. We have some things subtracted. So we can't cancel until we make that entire numerator multiplication. So let's keep going. We're going to do a bunch of, I think I picked the wrong color. Okay. We're going to make that entire numerator multiplication, but first we have to multiply out. So we're going to FOIL and distribute. Excuse me while I let the cat outside. Okay, so we're distributing that 3 to get 9x plus 15 minus. Now careful, let's FOIL this out and then we still have to distribute that negative. So many details to pay attention to. So foiling first, when I combine the outer and the inner, I get plus 2x. Last times last is minus 3. Some loud jets around here too. Okay, the denominator stays the same. Notice, nothing gets canceled out of the denominator yet. That denominator stayed the same for a long time in this problem. Is this a lot of work? Oh yeah. Can you do it? Oh yeah. Keep going, math stars. Let's distribute that negative into that trinomial. Negative x squared minus 2x plus 3. Whew. Don't cancel until the very end. If you notice, there's no canceling on this whole problem yet. Okay, in the numerator, combining like terms. Negative x squared plus 7x plus 18. Okay, so remember like 3 steps ago, I said that the goal was to make the entire numerator multiplication because then we can do our canceling. So I'm going to factor in 2 steps. I noticed a lot of you guys on your homework were factoring a negative and product sum in the same step, and you were messing up the signs. So let's factor just the negative first. Then leave the negative in front and factor using product sum method. And we get x minus, I think not 6 and 3, but 9 and 2 are going to work and give us the 7 here. So x minus 9x plus 2. Okay, good. So on this problem, nothing ends up canceling out. That's okay. Doesn't always happen. But when would we cancel? We would cancel on the very last step. So go back if you got a low grade on the performance task, go ahead and review that. Or if you have some questions on the homework, feel free to join me in office hours. Hey Math Stars, this is week 5 of distance learning. Today we're solving rational equations. So for 2 weeks already, you've been working with rational expressions, adding and subtracting last week, and the previous week was multiplying and dividing. So when you see an equation that looks like our first problem here, where we're solving this rational equation, if you have a single rational expression on both sides, you can just cross multiply. So to cross multiply, we're going to multiply the 8 and the x plus 2. So let's distribute the 8 to the x plus 2. So distributing, we get 8x plus 16. Let's multiply the other direction, and we're going to distribute that x to the x plus 8. So distributing, we get x squared plus 8x. Ooh, that's a quadratic. What form do we get a quadratic in before we can factor? Standard. Good job. So let's move everything to the right because I want that x squared to stay positive. So the x squared is positive. Let's subtract the 8x over. That cancels out the 8x on the right. And then let's subtract the 16 over. So, we get a beautiful difference of 2 squares. All differences of 2 squares are beautiful in my opinion. I love them. Let's go ahead and factor. This is x minus 4, x plus 4. So we get 2 solutions. X is equal to 4, x is equal to negative 4. We have possibly extraneous solutions. So when you have a rational expression like a fraction, you are not allowed to have a 0 in the denominator. That makes the expression undefined. So we would have an extraneous solution if there was a 0 in the denominator of either expression. So let's go up here to our original equation and look at the denominators, x plus 8 and 8. If I plug in a 4 or a negative 4 for that x, will either of those answers give me a 0 in the denominator? No. And neither of them obviously would make the second denominator 0 since there's not even an x there. So neither solution is extraneous. They are legit. That's a picture of our cat. I was just looking through photos when I was trying to find equations for this problem, and I saw our kitty in my photos, so just put him on there. That's Miley, big boy Miley. Okay, method 2. Let's multiply each numerator by the lowest common denominator. When do we do this method? Well, when we don't just have a single expression equal to a different expression. We have more going on here. On the left, we have this addition, so we don't just have a single expression equal to another one. Okay, so what is the LCD? The LCD is the lowest common denominator. Basically, when you find the lowest common denominator, you want to think no factor left behind. So the first thing we're going to do before we can find that lowest common denominator is we're going to factor each denominator. So we're going to rewrite and factor each denominator. This is the same step if you add or subtract rational expressions. So rewriting, the only denominator we need to factor is the one on the right. Leave some room while you're writing this step because next we have a lot of writing to kind of squeeze into this equation. So leave yourself some room because we're going to squeeze some stuff in here. So I'm factoring this denominator as x minus 2, x minus 7. Okay, so now let's think about the lowest common denominator. We want no factor left behind. In the denominators, I actually only see two different factors. I see a factor of x minus 2 and a factor of x minus 7. Those same factors also occur on the right-hand side, but they're not different factors. They're the same factors. So our lowest common denominator is x minus 2 times x minus 7. So our next step is to multiply each expression in the numerator by the LCD. We're multiplying each expression in the numerator by the LCD. Okay, so why do we do this? Well, this step is about to get really messy and ugly, but a lot of stuff is going to cancel out and we will have no more fractions. Repeat it with me, no more fractions. Okay, so let's multiply each expression in the numerator only by the LCD. So let's squeeze that x minus 2, x minus 7 into each numerator. You're like, Miss Kelly, you're kidding me. No, I'm not kidding you. You can do this. So what's really satisfying now is all of the fun canceling we get to do. X minus 2's cancel here. X minus 7's cancel here. X minus 2's and x minus 7's cancel here. Later in the week, when you do your performance task, you're going to have to answer a question about why do we cancel early in the problem when we solve? The reason we're canceling early in the problem when we solve is, look, no more denominators. All those denominators canceled out. And we're left with 3 and the quantity x minus 7. Here we have an x and x minus 2. And then on the right, all we have is a 5x. When you add or subtract, you do the canceling at the end. When you solve, you cancel early because it gets all those denominators out of the problem. Really simplifies it. By the way, when we add or subtract, we had to multiply on the top and the bottom of the expressions. Here we're only multiplying in the numerator. Why is that? Because of this little guy, this equal sign. You guys have been solving equations for years. And you know, if you do something to one side of the equation, it balances out if you do the same thing to the other side. Last week's homework, they were just expressions. There was no equation. We didn't have a left and a right-hand side of the equation to work with. So we had to multiply the numerator and denominator. But now since we have an equal sign, we're multiplying each term by the lowest common denominator, but only in the numerator. Okay. So let's go ahead and keep going. Let's distribute down here and we get 3x minus 21 and so on. And again, a beautiful quadratic. Let's bring everything to the left. We want that x squared to stay positive. So on the left, we have 3x minus 2x, which is x. Subtracting the 5x over, we get negative 4x. Okay, so I guess I need to get caught up on the steps on the right here. So what did we do after we multiplied each expression in the numerator by the LCD? Then we just did some distributing. And then we rewrote the expression in standard form, or rewrote the equation in standard form. Okay, now we're just going to factor and solve. Okay, so factoring, we're going to get x minus 7, x plus 3. Solving each of those factors for x, we get x equals positive 7, x equals negative 3. So remember, the solutions are extraneous if they make any of the denominators equal to 0. So the easiest place to check for this is after you've factored. So I'm going to circle these factored denominators. Will 7 make any of those denominators 0? Oh yeah, right there. So this guy's extraneous. We can't have a 0 in the denominator. -3 is not. So this one only has one solution. X equals -3 is our solution. So our last step is to check for extraneous solutions. So why did the rational equation get a poor grade in chemistry? Do you guys know? Why did the rational equation get a poor grade in chemistry? It kept producing extraneous solutions. Okay, last one. Number 3. This is the same method as the previous one. Let's go through it quickly because I think you guys have seen it once. We can go through it a little quicker. So the first step is to rewrite factoring only what? Only denominators. Can't factor that 2. Even if you have an x squared in the numerator, don't factor it. Only factor the denominator. The reason we're factoring the denominators is we can see the factors we need for our LCD, our lowest common denominator. Okay, so no factor left behind. When we find our lowest common denominator, every factor needs to be represented. Okay, we need a factor of 2. 2 is a different factor than x minus 2. So we need a factor of just plain old 2. We need a factor of x minus 2. And we also need a factor of x plus 2. Those are all different factors that are needed. Okay, and then when we get to the right, x minus 2 has already been used, so we do not need another one. Okay, so we're going to multiply by the lowest common denominator only in the numerator. So this is going to take a lot of work, but that's okay because a lot of the stuff's going to cancel. So we're going to squeeze in here 2x plus 2, x minus 2. And then here 2x plus 2, x minus 2. And again. Now, if you like to color code things, you might want to do this step like I did in a separate color. You might want to highlight where you're multiplying by the lowest common denominator. I just like to do that because there's so much writing. It just helps me to keep organized. So cancel, baby. Whoop. Canceling these 2's. Next one. Whoa, this is awesome. We get to cancel the x minus 2 and the x plus 2. Get rid of that unwanted baggage in our lives. Let's get rid of those denominators. X minus 2 cancel. Okay, so what are we left with? Let's rewrite everything that we're left with. So here, x plus 2, x minus 2. I'm just going to rewrite everything that remains so we can kind of evaluate and take stock of what we have. Oops, that's an equal sign. 3 and 2. Okay, we're going to FOIL, we're going to distribute, we're going to see if we can get this in standard form. So let's have at it. Let's FOIL this out. Well, that's just going to be a difference of 2 squares. Here, let's distribute the 2. And then on the right, we're going to have a 6 here. Let's distribute that 6. So that's going to give us 6x plus 12. Move everything to the right to get it in standard form. Let's combine these x's. So it looks like we're going to get minus 4x. Okay, let's combine the constants now. So we have a -4 and a 20. That's 16. And then let's subtract that 12 over. So it's 16 minus 12 is 4. Beautiful. Man, I've said beautiful like 3 times in this video. I must really love math. Yep. Factoring. Product sum. So we get x minus 2, x minus 2. So x is equal to 2. X is equal to 2. We're done? No. Check for extraneous solutions. So we're going to go back up to the numerator back up to the original problem, and look at these numerators. I'm going to box them. Let's see if 2 is going to make any of those denominators 0. Sure thing. 2 turns that denominator into 0. Sorry, baby. You have no solution. All right. Hey, upload a picture of these notes for me. Keep it honest with your homework. No photo math, no sending pictures to friends. Contact me if you need help. I love helping kids with math. We can get on a Teams meeting or Zoom call if you need help. Join me in my office hours. Work hard, math stars. I miss ya. Hope you're doing well.